Now let's cover the last type of transformation, which is translations in the x and the y direction. Determine the image of y is equal to x squared after translating 3 units in the positive x direction and 2 units in the negative y direction. So what we do is we just take our x dash and y dash equations and then we add or subtract our translation values accordingly. It's pretty straightforward when you think about it, and it's pretty intuitive. So x dash and y dash, we just get equations for them. X dash is going to be equal to x plus 3 because we're going 3 units in the positive x direction. So we'll get x plus 3 for that one. Then y dash is going to be equal to y minus 2 because we're going 2 units in the negative y direction. So we're taking our original y value minusing 2 because we're going in the negative direction. Sweet. Now the next step, just like always, is to rearrange for our traditional x and y, or our original x and y. So we end up getting x is equal to x dashed minus 3, and then y is equal to y dashed plus 2. And then we have our 2 equations here. And then what we do is we substitute these back into our equation. And what you're going to see in this next step is actually a reason why our turning point forms and just our general translation forms for x and y are slightly different for the x and y. For the x value, we usually take the negative of the x translation value, but then for the y, we just take the raw value. So if it's plus 2, it's translating up in the y direction by 2 units. If it's minus, then it's translating in the negative direction. And we're actually going to see in this next step why that's the case. So when we substitute in these expressions into y is equal to x squared, so we take y is equal to x squared, and we end up getting y dashed plus 2 is equal to x dashed minus 3 all squared. So you can see here in this form that it's currently in, without rearranging, that everything is the opposite sign. So y dash plus 2, so we have the plus 2 and the y, and we're actually going the negative direction, but then we're going 3 units in the positive x direction, and that's the opposite sign as well, because we have minus 3. But the thing is, when we have our traditional forms for equations, it's usually y is equal to something. So what we usually do is move this positive 2 to the other side to become negative 2. So y dash will be equal to x dash minus 3 squared minus 2. So what we've done with the y value is we first moved the negative 2 to the other side to become positive at this step here, but then we move the positive 2 to the other side again to rearrange it to become negative 2. So that's why for y translations or y values of turning points, the y value is the same sign that it needs to be because we moved it once across to one side and then we moved it across to the other side. We actually don't do the same for the x value. We swap the sign when we rearrange at this step here, but then it's inside our function, so we actually don't move it. So that's why the x translation just stays as minus 3, it stays as negative. So when we read it off this turning point form here, we just take the negative of that x value. We already know that we're going to take positive 3 and negative 2 for our translation values. Sweet. So last step is just our usual step. Therefore, the image equation is y is equal to x minus 3 squared minus 2. And the good thing about this is that we can just validate our final answer because we're given y is equal to x squared. And if we just translate it by 3 units in the positive x direction and 2 units in the negative y direction, we can essentially just use the opposite of our turning point form or try and put it into turning point form, because we know that when we do translations, we're essentially just shifting the graph or shifting the turning point and the overall shape. So we can see negative 3 there means a translation of 3 units in the positive x direction, and negative 2 there is 2 units in the negative y direction. And you might notice that even in the way that the question's worded and the way that I'm speaking this aloud, I say positive x direction, negative x direction. So it's obviously meaning that if we have our Cartesian plane here, this is x, that's positive, that's negative. And then we have our y, that's positive, that's negative. And when you're describing translations, we're going to talk about this in a future video anyway, but most of the time they're not going to say to the right, to the left, up or down. They usually specify the sign and then also the axes in which you're going in.